Hey guys, I wanted to create a quick video tonight to go over with you when we're going to use Roman numerals in the names and formulas of substances. And what it comes down to is anytime we see an element that's got a transition metal, we want to go ahead and use a Roman numeral. The easiest way to remember what the transition metals are by looking at the periodic table. Okay, so when we look at the periodic table, what we can see pretty easily is that the transition metals are the metals that fall within this block of elements right here. Okay, and anytime it's going to fall within this block of elements right there, it's going to be a transition metal. Now there are a couple of exceptions. Okay, so I want you to remember some of those exceptions. Okay, the first exception that we're going to talk about is going to be zinc. Okay, zinc we know is always going to be a +2 ion. Silver is always going to be a +1 ion, and cadmium is always going to be a +2 ion. Okay, so within that whole block here, okay, anything else that's within this area right here, we know are going to be transition metals. Now the thing about transition metals is that they can have more than one charge that are associated with them. So just for really simple conversation's sake, okay, if we look at copper, okay, this area copper right here, we know that copper can be either copper 1, copper with a 1 plus charge, or it can be copper 2, copper with a 2 plus charge. Okay. Similarly, we've got titanium. Titanium can exist in the form of titanium 2. It can also be found in titanium 4, and so on and so forth. Okay. So the easiest thing for us to do is to look at a couple of examples. When we're trying to come up with the compound that is made up with transition metals, we have to remember a couple things. First of all, when we look at the name of the compound, the name of the metal goes with the Roman numeral. Those are all linked together. So what that tells us is we're talking about vanadium with a 3 plus charge. Okay, when we look at our periodic table for bromide, we know that we can find Br. It's got a -1 charge. Now it's just straightforward the way we've done it with everything else. We've got a total 3 plus charge here, a 1 minus charge here. In order to make it neutral, you have to have the formula VBr3. Similarly, for tin 2 cyanide, we know that tin 2 all goes together, so it's going to be Sn with a 2 plus charge. Okay, cyanide is a polyatomic ion, Cn with a -1 charge. So we can see that we're going to need 2 cyanides for every 1 tin in order to make a neutral compound. Sn parentheses Cn close parentheses 2. Tungsten 2 phosphate. Okay, keeping in mind that tungsten 2 all goes together here. Tungsten is W. We know it's going to have a 2 plus charge because it's tungsten Roman numeral 2. Phosphate is PO4 with a 3 minus charge. In order to make a neutral compound here, we need 3 tungstens and we need 2 phosphates, giving us the formula of W3, 3 tungstens, and 2 phosphates, PO4, 2. Okay, I put silver nitrate in here because silver, remember, is a transitional metal based on its location on the periodic table, but silver is always going to be +1, so it's going to be Ag+. Nitrate is always going to be NO3 with a 1 minus charge because it's a polyatomic ion, giving us the formula of AgNO3. So for just some mixed practice, we can tell by looking at the by looking at the name of the substance that these are going to be transition metals because they have the set charge associated with them in Roman numerals. Silver, even though it's located within that block, does not have a Roman numeral, and we know that it's always going to be +1 charge. Okay, now let's go the other way. Okay, we've got a situation now where we want to try to figure out what the name of these substances are. So when we have to try to figure out the name of the substances, what we need to do is we need to dissect what's made up of. Okay, we don't know anything about the chromium in this case because it could be chromium anything. When we go back to our first page, we can see that the chromium can be any number of charges. So we have to use the hydroxide, which is always going to be a -1 charge. There are 3 hydroxides, giving us a total of a -3 charge. We know that we want all of our compounds to be neutral or equal to 0, so we know that the total positive charge has 3 plus. Because there's only 1 chromium, that means each chromium must be a +3. The name of the substance would therefore be chromium, Roman numeral 3, hydroxide. Chromium 3 hydroxide. We can look at this substance here as well. Okay, we know that iron is a transition metal based on its position on the periodic table. We know this substance is called carbonate, so the skeleton is going to be iron with some Roman numeral that we have to fill in. Carbonate, Now it's just a matter of trying to figure out what it is. Well, carbonate is going to be a 2 minus ion. There are 3 of them for a total of 6 minus. To make a neutral compound, we want it to be 6 plus. We can see that the 6 plus is going to be shared across 2 irons in the formula. That makes each one 3 plus. Therefore, it's going to be iron 3 carbonate. Okay. This substance here, we can see that Cu is copper, Cl is chloride. Copper is a transition metal, so it's going to be copper something chloride. Okay, come back over here. Each chloride is going to be -1. There are 2 chlorides for a total of -2. The total positive charge has to be +2. Because +2 is only going to 1 copper, each one is going to be +2, giving us a copper 2 chloride substance there. And then down here, this one looks a little funny. That's actually an I. So it's going to be titanium something iodide, okay, because it's coming from iodine. We know each iodide is -1. There are 4 of them for a total of -4. Your total positive charge would be +4. There's 1 titanium. That means it must be +4, so it'll be titanium 4 bromide. Okay, so keep in mind the only time we're going to use transition metals, the only time we're going to use Roman numerals, I should say, are when we have transition metals. Okay, transition metals have Roman numerals. Okay, and the key is that the Roman numeral is equal to its charge. Okay, so good luck. I hope this is sufficient for you. I hope it's able to help you out, and I wish you luck as we continue to work our way through chemistry.